Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video we started with the closed loop configuration of Opamp and I showed you certain application. So what we saw? Inverting amplifier, inverting summer we saw, okay. Then we also saw non-inverting amplifier. All these type of application we covered in the last video. Now in this lecture we'll continue from where we left off and we'll study some other applications of the negative feedback configuration or the closed loop configuration. So the next circuit is your voltage follower. Now initially here I'll assume that, what should be my first assumption? That open loop gain tends to infinity, and due to this negative feedback, plus we have negative feedback, the combined effect of them is that virtual ground can be applied, okay. We can apply the virtual ground. In that case, what we will say is Vp should be equal to Vn should be equal to Vs, okay. That is the source voltage. Now see this negative terminal is directly connected to output. Vn is actually V0, which will become equal to Vs. So here you can see that output voltage is equal to supply voltage. Therefore this circuit is called as the voltage follower, because output will follow the supply voltage, hence it is following the voltage input to the amplifier, or it is voltage follower, okay. It is very much analogous to what we were studying in BJT under the name ammeter follower, or in MOSFET source follower. In both those amplifiers we saw that the voltage gain was nearly 1. So input and output voltage were almost same. So that is the same thing we are doing using an Opamp. We are implementing a kind of voltage buffer, okay. It can also be called as the voltage buffer. What is a buffer? A buffer is a device which passes the signal to the output as it is. It does not modify the input signal, okay. So that is what it is working as, a voltage buffer. Moving to the next application, non-inverting summing amplifier. Earlier we were talking about inverting summing amplifier. Same way we have non-inverting summing amplifier. Now in this case, what is the procedure? Here we use superposition principle. Now the question that might be coming to your mind is, why we are using superposition? We directly solved for the case of inverting summing amplifier. Why we need superposition for the non-inverting? See, the reason is, even if you apply virtual ground by assuming open loop gain to be infinite, you can only say that Vp is equal to Vn. But you cannot tell their values, okay. The values here are unknown, so we won't be able to do much with this analysis. So what I will do is, I'll try to find out Vp using superposition. So how will I use superposition? Let me first assume only V1. If I am only assuming V1, V2 and V3 will be grounded. If both are grounded, and then R2 and R3 are in parallel, right? See this way, if you ground both V2 and V3, R2 and R3 will be in parallel, and the voltage of this terminal is, let us say, Vp1. This is V1. So by voltage division, what you can say, Vp1 is V1 into the equivalent is R2 parallel R3. And since we are applying voltage division between these resistances, you will say R1 plus R2 parallel R3. Because the voltage across this parallel combination is the voltage VP1. Similarly, when you consider V2, you will ground V1 and V3. In that case, R1 and R3 will come in parallel. So what you will say? VP2 is V2 into R1 parallel R3 by R2 plus R1 parallel R3. Okay. Similarly, when you talk about V3, you will ground V1 and V2. So VP3 will be V3 into R1 parallel R2 by R3 plus R1 parallel R2. Now by superposition, you can say VP is VP1 plus VP2 plus VP3. That means what you can do now is, instead of this entire circuit, what you can do is, you just replace it with a source here, VP, then this circuit. Okay, this is V0, RF, R1 and ground. Now this is simply a non-inverting amplifier. I told you, remember the gain of non-inverting and inverting amplifier. Based on that, what I can write out? I can find the value of V0. V0 is VP into gain. What is the gain? 1 plus RF by RI. Okay, this is RI. Now suppose if I take R1 equal to R2 equal to R3. Suppose they both are, all are R. In that case, what should be the parallel combination of equal resistances? R by 2. So VP1 will be V1 into R by 2 by R plus R by 2. So that is V1 by 3. Similarly, VP2 and VP3 will also come out to be, or VP2 will be V2 by 3 and VP3 will be V3 by 3. So if all resistances are equal, then all the three voltages become divided by 3 in the process of voltage division. Okay. So now when you write out V0, VP is V1 plus V2, sorry, VP1 plus VP2 plus VP3. V1 plus V2 plus V3 by 3. 1 plus RF by RI. Now take case 1. If your RF is 0, if this RF is 0, then this circuit becomes voltage follower, right? So V0 is V1 plus V2 plus V3 by 3. What does this become? This becomes average. Take case number 2. RF equal to 2 RI. If RF upon RI becomes 2, 1 plus 2 will be 3. 3 will get cancelled. So V0 will be V1 plus V2 plus V3. So it becomes a sum. So that is, we can find out the sum as well as average of the three voltages using this circuit. You can also have more voltages instead of 3, like we can also have 4 or 5 voltages. So if you want to have average of certain values by using an analog circuit, then what you can do? You can make use of the non-inverting summing amplifier. Okay. So the previous two circuits that we have seen, voltage follower and the non-inverting summing amplifier, they are modified versions of the non-inverting amplifier only. So we have just modified that circuit and realized a new circuit. The next and one of the most important circuit is your differential amplifier. What did I tell you about differential amplifier even in open loop configuration? A differential amplifier is an amplifier that amplifies the difference of the two voltages. Okay, so that circuit we are constructing here. So remember, what is differential amplifier? An amplifier which amplifies the difference of the two voltages. And what is the objective in differential amplifier? We want to have a large value of differential gain but a very small value of common mode gain. I told you about common mode gain also earlier. I told you it is the gain offered to the signal that is common to both the terminals. And what is that signal usually? That signal usually is the noise. Okay, so noise is always common to all the input terminals. We want to attenuate the noise and we want to amplify the difference. So we want a large amount of differential gain but a small amount of common mode gain. So in differential amplifier, what I'll do is, in order to analyze, I'll make use of superposition principle. Okay. So first of all, I'll consider V1 is not equal to 0 but V2 is equal to 0. So this will be grounded. Now the current here is 0 ampere, which means these two are in series. So we can find out VP. VP can be found out using voltage division V1 into R3 over R2 plus R3. Now since you have grounded this V2, you can draw this circuit like this. This source here is VP. This is R1. This is RF. Okay. Now this is simply a non-inverting amplifier. And what is the output voltage of non-inverting amplifier? VP multiplied by gain. Gain is 1 plus RF over R1. RF is the feedback resistance. R1 is the resistance connected at the inverting terminal. So V1 R3 over R2 plus R3 into R1 plus RF over R1. Okay. Now we will consider V1 equal to 0 but V2 not equal to 0. Now if you ground this V1, both will then be in parallel. Why they both will be in parallel? These terminals will be connected together. So both will come in parallel. If both are in parallel, then this VP will become 0. If this VP becomes 0, so what you can do now is, you can directly ground this terminal and this voltage is V2. So what is it now? It is it is an inverting amplifier. What is the gain of inverting amplifier? V2 into minus RF by R1. So you can say that overall V0 is V01 plus V02. V1 R3 over R2 plus R3, R1 plus RF over R1 minus V2 RF by R1. Now here we cannot directly say that it is simply the difference or it is amplifying the difference of the two voltages. You cannot directly say that. So if you want to find or if you want to amplify the difference of the two voltages, what you have to do is, you have to consider if R1 equal to R2 and R3 equal to RF. Okay. Now, in that case, R2 plus R3 will be R1 plus RF. So, V0 will be V1. This term will get cancelled, R1 plus RF and R2 plus R3. It will be V1 into R3 by R1 minus V2 into RF by R1. Now R3 is same as RF. So RF can be taken common, RF by R1. V1 minus V2. This you can write as AD VD, where VD is nothing but the difference of the two voltages V1 minus V2, and AD is the differential gain, which comes out to be RF by R1. Okay. So that is the output voltage in this case. So you can say that the amplifier is amplifying the difference of the two voltages, that is V1 and V2. Now if you keep R1 and RF also equal, then this differential gain will come out to be 1. Okay. In that case you can say that the difference will be multiplied by 1, and V0 will be simply V1 minus V2. Now let us find out one important parameter for a differential amplifier, that is CMRR. For CMRR, in open loop configuration, when we were studying the specification, I told you one thing. V0 can be written as A1 V1 plus A2 V2. Just now we have derived what is the gain of V1. V1 has this much gain, that is R3 over R2 plus R3 into R1 plus RF over R1, that is A1. What about A2? A2 is minus RF by R1. Now we know that differential mode gain is written as A1 minus A2 by 2. What about common mode gain? It is simply A1 plus A2. If you see A2 is negative, so A1 plus A2 will be less than A1 minus A2. Then what we say is CMRR is nothing but the ratio of differential gain to the common mode gain. Similarly, CMRR in dB is 20 log on a base of 10 AD over ACM. Okay, so that is the value of your CMRR in dB. Okay, so if you want, you can also express it completely. AD is A1 minus A2 by 2, ACM is A1 plus A2. So there we are not approximating anything, we are just taking the value of A1 and A2. Now if you want if CMRR should tend to infinity, in that case ACM must tend to 0, or you can say A1 plus A2 must be 0. A1 was R3 over R2 plus R3, R1 plus RF over R1 minus RF by R1. This must be 0. So you can write it like this: 1 plus R3 by R2, 1 plus RF by R1 minus RF by R1. If you say now that R3 by R2 is equal to RF by R1, in that case this term will be 1. So 1 minus RF by R1 must be 0, or you can say RF should be equal to R1. Okay, RF should be equal to R1. In that case R3 should be equal to R2. So if you want infinite value of CMRR, which is the ideal value, then in that case RF and R1 must be equal, and R2 and R3 must also be equal. Is it fine? So that is how we can say that we can achieve an infinite value of CMRR which is desirable, or you can say the common mode gain would be 0. Common mode gain being 0 means the common mode signal will not be passed, or common mode signal will become 0 at the output. Now suppose I want to find the differential input resistance. In differential amplifier, one important parameter is differential input resistance. So let me redraw the differential amplifier. Okay. This was the circuit. To find the differential input resistance, what you have to do is, you have to connect a signal between the two terminals. Suppose this is V, I find out I. So what is the differential input resistance? It is V by I. So whenever I ask you to find the differential input resistance, what you will do? You will connect a source between the input and the output terminal, between the two input terminals, and find the ratio of source voltage and source current. That is how you can find the differential input resistance always. So now in this case, if open loop gain tends to infinity, then we can apply virtual ground, right? Virtual ground means the voltage of positive and the negative terminal must be same. So what I'll do is, I will short this. So if I apply KVL, what I'll say, V minus IR1 minus IR2 equal to 0. So V by I, which is RID, is simply R1 plus R2. So in differential amplifier, I can also ask you to find the differential input resistance, that will come out to be R1 plus R2. So remember this method. Okay. So this is the very important method in which we can find the differential input resistance. What if I ask you to find the resistance input or the input resistance at each terminal? Okay. Suppose I want to find input resistance at non-inverting terminal. In this case, what you do is, you connect a source here and find this current I. Ground this. Since no current goes into Opamp, right? So this current I will go like this. So if I apply KVL, V minus IR2 minus IR3 equal to 0. So what is V by I? R2 plus R3. So that is the resistance at the positive terminal. What about input resistance at inverting terminal? In that case, where will you connect the source? We will connect the source at the inverting terminal and we will ground non-inverting terminal. Okay. So if you have grounded this non-inverting terminal, what is the voltage here? 0 volt. By virtual ground, what is the voltage here? 0 volt. So what is this I? V minus 0 by R1. So V by I equal to resistance of negative terminal is equal to R1. So we can find three resistances, either the resistance at the inverting terminal, the resistance at the non-inverting terminal, or we can also find the differential input resistance. Okay. So these three resistance I can find. So what questions can be asked in differential amplifier if I list down? First, differential gain, common mode gain, CMRR, R positive, R negative and RIT. So all these things can be asked. So this differential amplifier is very important. You have to remember how did I analyze this differential amplifier. The next application is called as instrumentation amplifier. Now this instrumentation amplifier is also a differential amplifier but it is a modified version. How it is modified? There are two more op-amps connected at the input terminals. So this is called as your, the op-amps at the input, this is called as your buffer stage, and later on we have differential amplifier. So if we have buffer stage in a differential amplifier, then it is called as an instrumentation amplifier. Now what is the benefit with instrumentation amplifier is that due to the buffer stage at the input, impedance matching is easier. Impedance matching means when input and the output impedance is equal, which is also called as maximum power transfer theorem in network. Impedance matching will be easier if you connect the input buffer stage. Okay. So what are the advantages of instrumentation amplifier? It has low offset voltage as compared to differential amplifier, high CMRR, higher than your differential amplifier, high input resistance and high gain. So these are some of the advantages that we are getting with instrumentation amplifier more as compared to your differential amplifier. Now how do we analyze this circuit? See, V2 is connected at the non-inverting terminal, V1 is also connected at the non-inverting terminal. So if you find out Vy, this is simply a non-inverting amplifier. This is simply a non-inverting amplifier, both above and below. Okay. So if you want to find out Vy, I'll apply the gain of non-inverting amplifier 1 plus Rf. Rf is the feedback resistance, R3 by R. R is the resistance connecting the negative terminal to ground. Similarly, by non-inverting amplifier, what should be Vx? The input is V1. This is also a non-inverting amplifier. V1 1 plus R3 by R. That is why I was telling you the formula for this inverting and non-inverting amplifier is very important. It helps us in solving multiple problems. Now if you see that if I find out the voltage of positive terminal, I have to apply potential division. So V positive is Vx into R2 over R1 plus R2. Now what you can do is, for the second stage, you can apply superposition Vox. Once you have positive terminal voltage, you consider that Vy equal to 0. I am applying superposition. I am assuming this source is equal to 0, so I am taking only second source. For second source, it is nothing but a non-inverting amplifier, so it is V positive into the gain 1 plus R2 by R1. That is Vx R2 over R1 plus R2 into R1 plus R2 by R1. So it is Vx into R2 by R1. Now take second case. Assume Vx equal to 0. If Vx is 0, this becomes grounded. So this is nothing but a inverting amplifier. So V0y is Vy gain of inverting amplifier minus R2 by R1. That is feedback resistance upon R1. So V0 will be V0x plus V0y. That is R2 by R1. Both have gain R2 by R1 into Vx minus Vy. Okay. So that is the output of the amplifier. But Vx and Vy both are amplified by a factor of 1 plus R3 by R. That is why I was saying the overall gain is high. So you can say V0 is 1 plus R3 by R into R2 by R1, V1 minus V2. So as you can see, two gains are being multiplied, 1 plus R3 by R and R2 by R1. Is this fine for all of you? Okay, this is very easy. First, what I have done in the buffer stage, I have identified that it is a non-inverting amplifier. I have found out the output of the buffer stage, and then I have used it as an input to the differential amplifier and found out the output of the differential amplifier. Now, what is the drawback of that configuration? If suppose there is a noise at V1 and V2, if there is noise or common mode signal at V1 and V2, then we have seen that Vx is V1 1 plus R3 by R, Vy is V2 1 plus R3 by R. That means noise gets amplified by what factor? By a factor of 1 plus R3 by R. So that is what is happening in instrumentation amplifier. The common mode signal or the noise signal is also getting amplified by a factor of 1 plus R3 by R. So that is why we have changed the configuration slightly. How I have changed? Suppose if A1 equal to A2 tends to infinity, that is the open loop gain of both the op amps is infinite, I can apply the concept of virtual ground. Okay, we can apply virtual ground. In that case, the voltage here will be V2, the voltage here will be V1. The voltage of both the terminals will be equal. So what is this current I? I is simply V1 minus V2 by 2R. Now this I current cannot enter the op amp. So this current will be I. Similarly, I cannot enter this terminal. So this current will also be I. Now apply KVL like this. So what I'll say, Vy or Vx minus IR3 plus or plus V2 minus V1 minus IR3 equal to 0, equal to Vy. So I have applied KVL going from Vx to Vy like this. From here you can find out Vx minus Vy. It is 2IR3 plus V2 minus V1. Okay, so plus V1 minus V2. Now I is V1 minus V2 by 2R. If you substitute that, V1 minus V2 can be common, 1 plus R3 by R. So what is happening here is Vx and Vy cannot be individually computed. We are directly computing the value of Vx minus Vy. So you can say common mode signal, the signal that is common to both V1 and V2, gets cancelled. Earlier in the previous circuit, if you see, we were first calculating Vy and Vx. If you were calculating Vy and Vx separately, the common mode signal will pass from input to the output. But if we are directly computing the difference of Vx and Vy, and there is some common term going in Vx and Vy, then that term will get cancelled out. Okay, so we cannot calculate Vx and Vy separately, we are calculating their difference. So if there is some signal common between V1 and V2, it will get cancelled. Moving on to the next application, that is integrator. What does an integrator do? it gives an output proportional to the integration of the input signal. Okay, the output should be proportional to the integration of the input signal. So let me show you how do we analyze this. At t equal to 0, we are closing this switch. So this current I will start to flow. Assume that open loop gain tends to infinity. In that case, you can say that positive and negative terminal voltages are equal. So that is 0. So here we have 0 volt. So what is this current I? I will be V minus 0 by R, or you can simply say V by R. This current cannot enter the input terminal of op-amp. It will go into capacitor. If current I is flowing in capacitor, what you can say? C dVc by dt is I. Remember, this expression can only be applied if current I is entering the positive terminal. Apply KVL also here. 0 minus Vc is V0. So Vc is minus V0. If you put here C d by dt, minus V0 is I. So minus C dV0 by dt is I. Or you can say dV0 by dt is minus I by C, or minus V by RC. So if you want to find out V0, what you will do? Minus infinity up to t minus V by RC dt. Or you can say minus 1 by RC integral from minus infinity to t v dt. That is, if you see, the output is proportional to the integration of the input voltage, and that is the purpose of the integrator. But always remember, there is a term of minus 1 by RC outside. Okay. So if you apply a square wave, its integration will be a triangle wave. Okay. Or it might be a sawtooth wave. That depends how you are operating the switch. It might be a triangle wave or it might be a sawtooth wave. Okay. Also, just integrator, you don't have to memorize any expression. Just apply the concept of virtual ground and simply KVL and KCL. If you exchange the value of resistance and capacitance, then we realize opposite circuit, that is differentiator. So what does a differentiator do? A differentiator will give an output proportional to derivative of the input signal. So it can give you the time rate change of the input voltage or rate of change of the input voltage. So let us see how we will analyze this circuit. At t equal to 0, you are closing this switch. Now by virtual ground, what is the value of positive terminal voltage and negative terminal voltage? It is 0 volt. Okay. So from here I can say that Vc is Vin minus 0. Since current I is entering the positive terminal, it will be C dVc by dt, C dVin by dt. Okay. That is the current. Now we very well know current cannot enter the input terminal of op-amp. So this current will go upwards. Okay. So what you will say is 0 minus V0 by R is equal to I. So V0 is minus IR. That is minus RC dVin by dt. So you can say that V0 is proportional to dVin by dt, or we are getting an output proportional to the time rate change of input. Also see the factor external to it. In integrator, what were we getting? In integrator, we were getting minus 1 by RC. In differentiator, what we are getting? Minus RC. So we are getting reciprocal of the previous factor. So just this circuit will work in opposite manner to the integrator circuit. Okay. Now this circuit has two main disadvantages. What are those disadvantages? See, the first disadvantage is at high frequency 1 by omega c will tend to 0. If this impedance becomes almost 0, this current I will tend to infinity. This current I will become very high if impedance of the capacitance is very low. That means high current flows at high frequency. This is fine. And you know that V0 is minus IR. If current is high, V0 will also be high. That means V0 will be very high at high frequency. Now think one thing. If I ask you one question, where can we see high frequency? Remember, most of the high frequency signal are noise signal. Noise always has high frequency, and that is what I mean to say here. V0 will be very high for noise. Let me show you an example. Suppose Vn is Vm sin omega t plus a small noise, suppose 0.01 Vm sin 10 to the power 6 omega t. Now when you take dV in by dt, what you will get? Omega Vm cos omega t plus this 10 to the power 6 will come outside into 10 to the power minus 2. 10 to the power 4 omega Vm cos 10 to the power 6 omega t. Now see, the noise amplitude is much higher as compared to the signal amplitude. So what does it mean? The noise will get amplified at the output and it may become higher than the signal itself, and that is undesirable. So this circuit has a disadvantage. So what we do is we connect a capacitor in the feedback. So at high frequency, what will happen? 1 by omega c will tend to 0. So CF will be shorted. If this CF is shorted, I flows through CF instead of R. If I flows through CF, then what will happen? Then this voltage, this is 0, this is short circuited, V0 will be 0. So no noise passes to output. Are you getting my point? What is the purpose of CF? At high frequency, CF will be shorted and will make V0 equal to 0. Then what is the purpose of this resistance? I told you at high frequency C is shorted. By virtual ground this voltage is 0. So I will be Vn by Rn. So it basically controls or limits the current. It will never let current reach a very high value. It will always limit the value of current. So Rn basically limits the value of current and CF makes the noise output equal to 0. There will be no noise at the output of the differentiator. So that is why we have modified or added these two elements in the differentiator. Now let us talk about the input and the output resistance of an amplifier. How do you calculate the input and output resistance when I give you any circuit? Okay. So if you want to calculate output resistance, how you will do it? First of all, open circuit RL. Because I have earlier also told you RL is not included in the output resistance. Short the voltage source and open current source. If there is current source, you will open circuit it, and if it is voltage source, you will short circuit it. Connect a source V0 at output terminal. Okay. Then R0 is simply V0 by I0, where I0 is the current supplied by the source connected at V0. So I0 is the current supplied by V0, and the ratio V0 by I0 is your output resistance. What about input resistance? It is simply V in over I in. You don't have to modify any circuit, just calculate input voltage by input current. Let us see in the first circuit. Which circuit it is? It is a non-inverting amplifier. We know that the current input to the op-amp is 0. So what is the input resistance? V in by 0, it tends to infinity. So input resistance will become infinite in a non-inverting amplifier. Okay. Next case, this one is an inverting amplifier. So by virtual ground, what you will do is, this voltage will be 0 volt. If this is 0 volt, I in is V in minus 0 by R1. So V in over I in is R1. It will be the input resistance. What about differential amplifier? Okay. What about differential amplifier? In this case, what we have to do actually is, the gain of this amplifier is taken to be A. Okay. We are considering A to be finite. Okay. So what is this voltage? What is the voltage difference between the positive and the negative terminal? The difference is minus V in. Why minus? Positive is connected to negative and negative is connected to positive. V0 is simply AVD. So it is minus A V in. So this voltage is minus A V in. This voltage is V in. So what is I in? I in is V in minus A V in by RF. So V in over I in is how much? RF over 1 plus A. Now if you say that A tends to infinity, then the input resistance would be 0. So for ideal amplifier, this input resistance will be 0, but for practical it will be RF over 1 plus A. So that is the basic technique that you use in finding the input resistance, always input voltage by current. So let me summarize what we have covered. I have told you about the concept of voltage follower. The second circuit I have told you about non-inverting summer. Okay. Then one of the most important circuit, differential amplifier. Here we use superposition. Instrumentation amplifier. What are the advantages? High gain, high CMRR, and it uses input buffer stage before differential amplifier. Then we saw integrator. Then differentiator. Differentiator basically amplifies the noise, so we modified the design by using one more capacitor and resistor. And then I told you about the concept of input resistance. Okay. So that is the linear application part of op-amp, in which output and input are directly proportional to each other. So in the next lecture, I will show you some problems based on these parameters or based on these circuits. Okay. That we will cover in the next lecture. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.